Yeah. So in last class, we have seen a few example like how to load data from one table to table, and one more thing we have discussed about execute SQL task. Execute SQL task. What it will do? We need to specify any SQL command inside of this, right? Inside of this. So here two things you need to remember. One is connection specification. That means second thing write a proper SQL command. So connection specification in the sense whatever the command you are trying to pass to the execute SQL task, right? So whatever the command you are trying to pass. So inside of the command, what you will specify generally, any stored procedure or else any kind of table or else any database object. Okay, so you need to specify a connection which will contain that particular database object. Okay, so that is what the connection specification and SQL statement. So in connection you need to specify connection, and in SQL statement option there you can specify your SQL command. Okay, so apart from this, what we have learned, precedent constraints, right? Precedent constraint where we use means whenever any kind of dependency, precedence constraint. So what are the three options? Visa, success, failure, complete. Okay, so when we'll go for success means first task should complete without any error. Okay, then only flow will move to next task. Okay, failure means first task will go for error, should fail, then only flow will move to next task. Complete means it won't bother about fail or success. Flow will move to next task. Okay, so that is what the dependency creation in between tasks. Okay, so generally where we will go for dependency. Okay, so this is what the important point we are going to discuss today. From source, whenever we are loading data from source to destination, okay, in real time, once we build a ETL, okay, so what we do is we will pull the data from source to destination, right? So from source to destination in the sense, source to, it might be to dimension table, or else it might be to fact table. Okay, we'll load the data into these two tables. Apart from this, what we will use, stage tables. Okay, so any other temporary tables which will support to load either dimensions or facts. Okay, but end of the day, what are the tables will go to warehouse means dimensions and facts. Okay, so these stage tables are temporary tables we use for temporary purpose. Okay, to hold the data temporary, and then we will use those tables to load manipulate data or else to do any kind of operations on top of source data, and finally load the data into dimensions and facts. Only these two kind of tables will exist in warehouse. Apart from these two, we won't contain any other table generally. That is what the warehouse style we will follow. So why we won't use means, like, if you keep on all unnecessary tables in the warehouse, it will occupy some database space unnecessarily. Okay, so to avoid all those kind of things, we won't load any other tables apart from dimensions and facts into data warehouse. So data warehouse will contain dimensions and facts. Here we have one thumb rule. Okay, what is that means? We should load dimensions first and then load facts. Why? Because, let me show you one example. Let us say I have sales business, right? So generally what kind of data, see, I assume like this is what sales data we are having. Okay, so we will have some transaction date. Okay, so whenever you go to any kind of supermarket or any sales center, what the data we will contain means, it will contain means date, when this purchase happened, and what is the product, what is the price of that product. Okay, what kind of payment mode you have done, credit card, debit card, or else any wallets, or else, okay, if you are using any kind of cards, like it may be master or visa card. Okay, and name, okay, city, your personal details like city, to which state and country. Okay, so create a date and the last time login. Okay, some your location related coordinates. Okay, so when you are loading this kind of this data into warehouse, we will separate the data into dimensions and facts, right? So dimension will contain descriptive data. Descriptive data. Fact contains measurable data. Okay, fact is nothing but the measurable data, dimension is nothing but descriptive data. So we will separate this data into dimensions and facts while loading into data warehouse. Okay, here a measurable data in the sense like price. Okay, in some cases we used to have some quantity also. Okay, quantity, how much quantity for a particular product, either two or else some 10 or else some 90, something like that. Okay, we used to maintain the quantity details as well. So all these, like, we can measure, we can sum, or else we can do some kind of mathematical operation on top of this data. Even price also we can sum it. Okay, end of the day, what is the total amount in my what we call in my wallet. So you need to you need to sum all those things. Okay, if you give any discount, so what is the total discount I have given. Okay, or else what is the what we call total selling amount on a particular product, or else what is the total selling amount on all the products. So likewise you can do some kind of mathematical operations. So this kind of data we will load into fact table. Okay, but what about date, what about product, and what about this geographical information like city, state, country, and latitude, longitude. Okay, so what about this created date and all. So we will move all this kind of descriptive data into dimensions. Okay, so let us say product information. We will create a dimension table for product. Okay, it will be like this. The table name will be dimension product, and it will contain some product ID, product name, okay, any model number if you have any specification. Likewise you may have other number of columns as well. So let us say product ID will be some 10203 something like this. Okay, product name is HTC and some model number is 820, HTC 820. Okay, and the product ID, another ID 20, some 204 10204, it might be some Sony. Okay, and model number is like something 20 S345 something like that. Okay, and 10245. Okay, it is something like. Likewise you will have some product details. Okay, and you are having date dimension. Okay, to save all the date information, transaction date or else account credit date, whatever it might be. Okay, assume like dim date. What it will contain? 1 2 3 something, some rows, and let's say date ID, date key, date, and some other information like uh, 1 2 3 4, and date is like 24th 01 June 2017, 02 June 2017, 03 2017. Likewise. Okay, so assume like you are having dimension geography with geographical information. Okay, geography ID, country, state, city, zip code. Okay, some geography ID 1 2 3 4 something like that. Country, some US. Okay, some Alaska. Okay, some AA, and zip code might be some, and UK. Okay, some ABC, and city like India, some, and city some, zip code is something like that. Okay, assume like we are having three different dimensions. Okay, so we have got this dimension table from the source data. Okay, we have differentiate, I mean like we have separated the source data into dimension tables, and we are also separating the fact data, right? So fact table might be some fact underscore sales. So in this particular fact table, what we will have is we will have some measure columns, quantity, price, okay, and some discounts, and parts sold. Okay, or else any kind of okay, any other some measures as per their business requirements. So if we have some quantity like 2 3 5 6 something like that, and price is some, and the discount is 20, some 45, some 56, 13. Okay, parts sold 20, 5, 60, okay, 45, something like that. So fact table will contain the information like this. But if you look at the fact table, and it is having price, quantity, discounts and parts sold. Inside of that you are having a record like this, 2 in 2020 and 20, which is a meaningless information. Why? Because how can you say that this is related to a particular quantity or a particular product or else particular date or else particular geography? How can you say that? You can't say if you have the data like this. Okay, so in order to give some meaning to the fact data, what we will do is we need to relate these dimensions with the fact table. Okay, so that relation is nothing but the primary key, foreign key relation. Okay, so primary key, from where you will get this primary key and where you put these foreign keys. Okay, if you come over here for a particular product, okay, many sales was happened over here. Okay, this is what product 1, product 2, again product 1, okay, again some product 2. Okay, so what are the distinct products over here? Product 1 and product 2. Okay, so whatever the distinct products available in the transactional information, that is from source, we will keep all those product information in your product dimension. Okay, so indirectly what we are saying is whatever the dimension table will contain, those records are unique. Okay, so HTC product and its model name, model number, we will insert one record, HTC 820. Again, in future you may get like a HTC, under HTC model you will get HTC 620. Okay, that means this combination will never repeat in the product table. This is different combination, this is different combination. Okay, so for each and every combination or else for each and every different product we will insert a single row in the dimension table, and each row will recognized by one unique number. Okay, so these are called as primary keys. Okay, these are called as primary key. Primary key is nothing but it will be unique and not null. I think you are aware of primary keys. Primary key is nothing but it will be unique in nature and the value should not be null. Okay, so for each and every product combination we will give one unique ID, unique identification number. Here also, let us say if you take geography table, okay, you will take all the different combination, country, state, city, zip. This is what one combination. UK, again, this is what one combination. Okay, you will take all different combination from here. State, city, country, if you have zip or else zip code or else longitude. Okay, we will take the different combinations and we will load the data into geography table. Okay, for each and every different combination we will give one unique ID. Here also for date dimension you will take all different dates. Okay, in general you need not to bother about the timing and all. Okay, in general we will take a date part only. Okay, so for each and every date we will give one unique identification number. Okay, so let us say all these products related to product 1. Okay, so assume like here first two are related to product 1. In that case you need to assign product ID. Okay, product 1 is nothing but, assume this is what product 1. What is its ID? 10203. 10203. 10203. Okay, this is related to Sony. Assume like this is related to Sony 4. Okay, so what is the ID for Sony? This is what the ID, and we will get this ID here. Now 10456. Product dimension, date dimension, geography dimension. Okay, so this is related to some 10456 assume. Okay, so instead of having product number and product model name over here, what we will do is we will take the ID from here and we will assign here. Okay, this we will do I mean like before loading the data into data warehouse. Okay, so for that purpose, first what we need to do is we need to load the dimensions. Okay, assume like this product table has not been loaded as of now. Okay, now this is empty. Okay, so and fact table has been loaded and it is having some product IDs. From where we got these IDs? We don't know. Why? Because in product table we don't have any data for product IDs, but in fact table we are having IDs, which is a meaningless information, right? So that's why before loading the values into fact table, first of all we need to load the product information into our product table. Okay, then only you need to get these IDs into the fact table. Here these are called as primary keys. Primary key is nothing but it will be unique. Okay, in the entire table one ID will not match with any other ID. Okay, and the value should not be null. Okay, definitely for each and every product we will have one unique ID. We can't leave this without ID like this. Okay, so that's why this is called as primary key, and we are referring these primary keys inside of the fact table. Okay, that's why this is called as a foreign keys. This will act as a foreign key. Similarly for geography also, we will get geography ID inside a fact table. Geography ID, let us say this cell is from US. What is the US Alaska? This cell is from this particular combination. What is the geography ID? 1. We will take this ID and we will keep 1. Assume like this transaction also happened from geography 1, and this transaction was happened from second, and this transaction was happened from second. Like that you can assign the IDs here. Similarly date. Okay, this is what happened on 2nd June. What is the ID for 2nd June? 2. We will take 2. And this is what this is also happened on 2nd June. What is the ID? 2nd. Okay, and this was happened on 4th June. Assume 4th June. What is the ID for 4th June? It is 4. And assume like this was happened on 3rd June. Okay, something like you will get the IDs inside of the fact table. Okay, so this is how like we will load the data into data warehouse. Okay, so before loading the data into fact table, we should load the data into dimension table. And once we load the data into dimension tables, okay, at the time of loading data into fact table, we will get the primary keys from dimensions and we will assign those keys into fact table as a foreign keys. Okay, so that is what the thumb rule. So primary keys should load first and then it should go for the foreign keys. So in this case there is a dependency. What is that? Dimensions should load first and then facts load happen. Okay, so what is the precedence constraint over here? On success. Success constraint you should give. Okay, so in real time the architecture or else any BI architecture, if you are working on MSBI, MSB architecture, whoever architect, okay, whoever is dealing with the customer, okay, from client side, they will give you the dimension table structures, okay, dimensions and fact structures, okay, like how you are going to load the data, what are the measures you want to have inside of the fact table, and what are the columns that you need to have in dimension table. All the specifications they will tell you. All what you need to do is you need to give proper names for each and every column, okay, and you need to give the names for the tables, proper names for the tables. And once after that, at the time of loading, you should take care of loading dimensions and facts like this, okay. So from source you will get the data, okay, and you may load the data into some stage tables. This is not the standard what we call standard flow, okay. This may vary from project to project, but at the time of the one thing you should remember is whenever we are working with the data warehouse, okay, the usage of staging table is mandatory thing, okay. Why? Because you may get stage data, and you will do some operations on stage data in the sense like incremental data, okay. Don't confuse with the terminology, you should remember all this terminology.
Can you explain this again, like the from source to stage tables? When do you use the stage tables?
Exactly, yeah, yeah. So incremental load, let me give you the history load. What is history load means, from source to, let us say the project is altogether starting from the scratch. So in that case, whatever the source system is having, let us say it may have 10 years of data, 20 years of data, okay. So whatever the entire data you are having, that entire data you will pull for one shot and load into dims and facts, okay. This is nothing but the history load. When we are loading the data into dimensions and facts, what we will do is we will get the source data into stage table, okay. Now your source table is having 20 years of data, okay. Assume like your source table is having sorry, your stage table is having 20 years of data. So now you are going to split the data into dimensions and facts, okay. So this stage table, from this stage table you will get the descriptive data into dimensions, okay. And still this stage table is having fact I mean measurable data as well. So now once after loading the data into dimensions, what you are getting, you are getting data into facts, okay. Getting data into facts is nothing but you are getting the data as usual from the source system. This is what the data you will get from source system, but you won't get these IDs from source system, am I right? So what we will do is you will use these dimension tables to populate all these columns. Let us say you need to populate product ID. How you populate this product ID? From product dimension table, okay. So in general I will tell you one more thing. Let us say this is what fact sales, right? So what we can do is let us say I'm removing all these IDs, okay. You are having your fact table is about to load all these columns, okay. So let me remove this entire thing. This is what your fact table, okay. So in your fact table you are having all these IDs and some measurable columns, okay. So now first thing is you want to populate this date ID. Okay, so how you will populate means you need to write an update statement. Update. What table you need to update? Fact tails, fact sales. Update fact sales. Set. What you are going to set? This date ID. Copy. Date ID equal to from fact sales. You are going to update date ID. Okay, so that means you need to join with the date dimension. Copy date dimension. Assume this alias is F and this alias is D, where D dot, that means in the date dimension, date value. Okay, it might be 1st June or it might be 2nd June or it might be 3rd or 4th. Whatever the date value you are having, that date value second, you need to use stage table and then you need to go for fact. Let me give you all the, you will come to know. Okay, so in the date dimension you will have date. Whenever this date is equal to what the stage table is having, all the source data. Okay, all the source data. So inside of the source data you are having transaction date. Okay, copy transaction date, st dot transaction date. Okay, then get the dimension, get the data ID from date table, date dimension table. Okay, delete. Let me give you a clear example on this. Assume like your source table is okay, some sales. Okay, source underscore sales, your source table name. Okay, and it is having columns like transaction date, product name, quantity, price, discount, and uh, customer phone number. Okay, your source table is having 4 columns: transaction date, product name, quantity, price, discount, cost. 1 2 3 4 5 6 columns your source table is having. Okay, now what you will do is you will create one stage table, st underscore sales. Okay, you will get all those columns into stage table. Now your stage table is having all these columns, right? So your stage table is having all these columns. Now you need to remember is you have created your fact table is already created. Okay, your fact table is having columns like trans date id, product id, okay, and quantity, price, discount, and some more columns like uh, revenue, something like that you are having. Okay, if you are if you observe here, transaction date id, product date id you are having in your fact table, Why? Because you are not going to populate this date and product name into the fact table. Instead, you are going to populate IDs. But from where you need to get IDs? You need to get IDs from dimension tables, right? So for that purpose, what we will do is you will create these two columns in the stage table. Apart from the columns you are getting from the source, you will have these two columns in the stage table. Okay. Now what you will do is you need to load the data into dimension product. Okay. So what data it is having? Assume like its columns are product ID, product name. Okay. Enough. These two columns it is having, and dimension date, date ID. Okay, and actual date. Likewise, you are having your product table, product ID, product name. Okay, and your dimension, date dimension is having date ID, date. This is what date dimension, right? So date dimension is having date ID and date. Now you have loaded, you are ready with your dimension product and dimension date. From where you have loaded? You have loaded from ST sales, stage sales. Okay, again from stage sales you have loaded this dimension as well. Now you need to load fact table from this table, from this stage table. Okay, don't confuse. First you are loading the data from source table to stage table. After that you are loading the data from this particular stage table to different dimension tables and different fact tables. Okay, this is what the flow. Now where are you? From stage to dimension product you have loaded, from stage to dimension date you have loaded. Now your attention is from stage to fact you are going to load. Inside of the fact, what you are going to load? Transaction date ID, product ID, quantity, price, discount, like this. Okay, but in stage table these two are empty columns now. Why? Because these two are not getting from source. Okay, that's why these two are empty. But at the time of loading the data into fact table, these two columns should have some data. So to have some data, we need to do some update statement. What is that? You need to write some update. What is that means? Update sales table, stage table, set this transaction date ID equal to some, we will give the ID from stage tables. And if you observe here, in which table you are having your date information? In date dimension. Date dimension, where wherever the transaction date in stage table equal to this particular dimension, where date in the date dimension, d dot date. Okay, then pick the ID from date table and then load it into transaction date ID. Okay, so indirectly what this update will tell you is in stage tails. Okay, let us say what is the transaction date you are having. Okay, this is, I assume like this is 1st June 2017. Okay, so 1st June 2017 is equal to, in date dimension are you having 1st June 2017? Yes, I am having 1st June 2017. Then 1st June 2017. this 1st June 2017 is equal to 1st June 2017. Then pick that related ID from date dimension. What is the related ID? 1. That will come over here and it will assign to transaction date ID. Okay, so likewise you will write another update for product ID. ST, and you are going to update your product ID. Where this product information will sit is in dimension product. You will take this dimension product and we will compare the product names. Okay, so what is the product name in the stage table and what is the product name in the dimension table? You are having product name over here, right? So what is the product name in the dimension table? And if both are same, then pick the product ID from dimension table. So likewise you will write the updates. Okay, once you write all the updates for all the dimensions, you will load the data into fact table, like insert into, we need to update an insert statement like this, insert into fact table, whatever the columns you want to populate. I want to populate all these columns. Okay, so likewise you may have many columns. From where you need to populate? Select from ST sales. Okay, so transaction date ID you are going to populate into fact. So you need to get the transaction ID. This is what the transaction date ID, and product ID, for product ID you are going to give this product ID from stage table. And for quantity, in the fact sales you are having quantity column, you are going to pick the quantity from stage table. Okay, so likewise for price, into price column you are going to populate a price. Okay, and for discount, after that you are having discount, right? So for discount you are going to populate discount and some other columns if you have. So likewise you will populate the data into fact table. Okay, why we need to have the IDs inside of the fact table is, fact table should never contain any kind of descriptive information. That is what the data warehouse formula. Okay, so that is why we are dividing descriptive data into dimension table. When we are dividing the descriptive data into dimension table, then what is the necessity of having the descriptive data in the fact table? We should not have that. So to avoid the things, you will maintain primary key and foreign key relation, and you will have IDs in the fact table. How you are going to get the IDs means likewise. Okay, you will join the stage table with your dimension table and you will compare the actual names. Okay, in your stage table you are having product name and in dimension table you are having product name. If both are matching, then pick the product ID for that particular record. Okay, it will get that ID for that record. So likewise it will populate the IDs. Okay, this is how you are going to write the insert statements or else SQL statements inside of your execute SQL task or else your store processor to load the data into either facts or dimensions. Okay, so let me show here. What is the involvement of stage means, like from source table to you are getting the data into stage table. On top of stage table you are doing all these kind of operations. Okay, so that's why we need stage tables. So we are not supposed to do these kind of operations on fact. Why? Because if you have your fact table over here, fact underscore fact sales. Okay, so copy underscore sales. Assume like you are going to update fact underscore sales over here. That means you are directly updating fact table based on product name. This is a meaningless. Why? Because in fact sales, are you having product name? You don't have product name. Okay, so that's why you are not supposed to write a fact table over here. You should write the stage table. Okay, and one more thing is why we should not write any update on fact directly means fact table will contain millions of records. That means like whatever the source table is having, okay, that many records it will have. If you write an update statement on I mean like on a huge volume of data, obviously it will give you some performance issues. Okay, so that's why we will avoid writing I mean like updates on a fact table. Okay, but what they will do for the first time loading, that means for the first time you will have the entire data in your stage table, right? So in that case you are going to update all the records at a time, so which is not a right thing. So instead of that, what they will do is they will update, they will divide the data into some chunks based on some condition. Okay, let us say we are having data from 2000 and now it is 2017. So instead of updating the data from 2000 to 2017 at test rates, we will divide the data into some chunks based on years. First we will update 2000 year 2000 data, then we will update year 2001, then we will update year 2002. Likewise we will do updates. Okay, so that is what the first time approach. Why? Because at the first time, at the time, I mean like when we are implementing MSBA and for a customer for the first time, we should get all the data, all the available data into our data warehouse. Okay, so for the first time we will do some chunks of data. From next time onwards we will get, okay, some part of data, that means recent records for 1 week rate, 1 week records or else 2 week records, like that. So in that case you don't need to apply chunks of data straight away. You can load the data. Why? Because uh, incremental load, it's nothing but incremental load, right? So for incremental you won't get that much of high volume. Okay, so in that case you need not to worry about loading the data in the, I mean like in chunks. 1 second. Okay, so before loading the data into stage table, okay, first time you have loaded the data from source to stage table, again you are trying to load the data from source to stage table. Okay, what will happen is stage table is already having some data, but again you are pulling some data from source to stage. Okay, so that means stage table will have old data and new data as well. So instead of that, what they will do is truncate the table, truncate stage table, and then load the data into stage table from source, which will have incremental data. On top of incremental data, they will apply all these kind of logics. Okay, this is not mandatory, like you will have the same updates in your real time. Okay, so based on your requirement, you need to write the updates or else whatever the operation you want. But this is what some example. Okay, so whatever the projects I have worked, so this is what the example from my experience, and most of the projects will go for the updates only. Okay, so why we need update means we need to get the IDs from dimension tables. So that's why we will go for updates. Once we update the IDs on stage table, those updates or else those IDs we will get into our fact table. Okay, so that is what the approach. That is what the usage of stage tables in data warehouse building. Okay, so end of the day, these stage tables we can truncate or else we can drop. Okay, drop stage tables. Okay, and we can create the stage tables on fly. Create stage table. Once after creating a stage table, load the data from source to stage. Likewise, 1 second. Create stage. Source to stage table and load data, update IDs or keys on stage table for facts and load data into facts. Once after completing loading the data into facts, that means like we have successfully done with loading dimensions and facts into our warehouse. Okay, but at the time of loading we can just drop or truncate stage tables. Okay, this is what the general flow. Okay, so if you are going to drop the stage table every time, then you need to create the stage table again at the time of execution. If you are going to truncate the table, that means table structure will remains. So in that case, you are not bothering about this creating the stage tables again. Okay, why? Because structure is ready, empty structure is ready. All what you need to do is you are going to load the data. That is what the principle. Okay, so this is what the general flow of loading the data into data warehouse. Okay, create the stage first and then get the data from source to stage. After that, I mean like using the stage table data, you will split the data into DEMS and facts. Once that is done, your data warehouse loading is completed. Okay, so that is what the general flow. So likewise, the precedent constraint. Here loading at the time of loading, like you will give for this particular flow, you will go, you will use this precedent constraint. Okay, for this flow, you need to use a precedent constraints. Okay, so likewise, execute SQL task or else data flow task or else precedent constraint. Okay, these are the primary things. Okay, wherever you go or else whatever the project it might be. 99 projects or else 99 packages will use all these three combinations. Execute SQL, data flow task. For some packages you may have only data flow task. For some packages you may have only execute SQL task. But end of the day, these are the primary components in MSPA. And precedent constraint. These precedent constraint you will use all the packages. Okay, that's what the mandatory thing. Generally, you can tell like it's what the mandatory thing to use precedent constraint. It might be success constraint, or else it might be failure constraint, or else it might be completion constraint. Whatever the thing it might be, you should specify some constraint between the components. Okay, so that is about the data warehouse, basic terms and basic flow. And we'll see about tomorrow's class. Like we'll plan to have the class